Okay, next we're going to take a look at the surface area and volume of pyramids and cones. So first, when we're talking about a right pyramid is a pyramid whose sides are triangles and which has its apex, the very top or the very peak of it, is aligned over the exact center of the polygon base. So this has to be exactly in the center of this square shape on the bottom. I'd get the same thing for this pentagonal pyramid, where once again the apex is going to be in the dead center of this pentagon. Ruby designed a right prism and a right pyramid out of cardboard for a grade 8 volume assignment. The right pyramid had an identical base and the same height as the prism. Max, her little brother, took the right prism and right pyramid from her room and played with them in a sandbox. He filled the pyramid with the sandbox and emptied the sand into the prism. He continued to do this until the prism was full of sand. And he repeated the whole process and discovered that each time he could fill the prism with 3 pyramids of sand exactly. So, how does the volume of a pyramid compare to the volume of a prism with the identical base? The volume of a pyramid is equal to exactly 1/3 the volume of a prism. If we're dealing with a right circular cone has a circular base and its vertex directly over the center of the circle. If we're writing a formula connecting the vertical height and the slant height and radius of this, well, I can see that the radius, the slant height going up the side of a face, and the vertical height going from the apex to the center of the base create a right triangle. In this case, the slant height squared is going to equal the radius squared plus the vertical height squared. We can just use Pythagorean theorem in order to solve if we're missing one of these. The volume of a right circular cone is the exact same process as if I had a cylinder with the same base compared to the cone, just like what we had with the pyramids. How does the volume of a cone compare to the volume of a cylinder? The volume of a cone is equal to exactly 1/3 the volume of a cylinder with the same dimensions. If we're talking about the surface area, it's just going to be the area of the base plus the area of the triangular faces. For cone, it's the area of the base plus the area of the curved surface, and the area of the curved surface is pi times r times s, which is not the vertical height, but the slant height going up the side of the cone. If I'm looking at volume, the volume of a prism is the volume of a pyramid is 1/3 the area of the base times the height, and the volume of a cylinder is 1/3 pi r squared, which is the volume of the base, times the vertical height. So, if we're putting into practice, for example 1, the Great Pyramid of Giza is considered to be one of the 7 wonders of the ancient world. It is approximately 147 centimeters tall, which is its height, and has a square base with sides measuring 440 meters. Make a sketch of the pyramid and calculate the volume to the nearest cubic meter. Well, if I'm doing a little SketchUp of this, doesn't have to be exact, then I know that I'm going to have a vertical height from the peak to the bottom of 147, and I know on the base this is going to be 440 meters by 440 meters because I have a square base. if I'm calculating the volume of this, the volume is going to equal 1/3 the area of the base, 440 times 440, times the vertical height, 147. This is going to approximate 9,486,400 meters cubed. If I want to make a sketch of the net of the pyramid and calculate the surface area to the nearest square meter, then what I'm going to do is I'm going to say that I would have the square base, and then from there, if I folded it open, I'm going to have identical triangles that come out on each side. I know that this is 440 and this is 440. Currently, I don't know what that slant height is, but I can solve for the slant height by saying that if I turn this into a right triangle and had the slant height up here, then the slant height squared is going to be equal to half of the base length squared plus the height squared, which means that the slant height, when I'm solving this, is going to equal 220 squared plus 147 squared. S squared is going to be 70009, which means S is going to equal the square root of that. And that's going to be about 264.59. Now, when I'm accounting for the surface area, why is the base, why is the square on the bottom not included in this? Because it wouldn't be out on the surface. Anytime that we have a building, it's not going to be exposed. When we talk about surface area, it's about exposed surface. But if it is an actual building, like if we're thinking about painting the outside of a barn, we wouldn't get underneath the barn, underneath the floor to paint it, because it just doesn't make sense. So really, my surface area is just going to be these 4 identical triangles. And the 4 triangles are going to be 4 of these 1/2 times the base, 440, times the height, which in this case is the slant height. Which means that my surface area in this case is going to be 232,841 meters squared if I'm going to the nearest whole meter squared. A cone-shaped container has a height of 15 centimeters and a base diameter of 16 centimeters. Determine the volume and surface area of the cone of the container to 1 decimal place. Well, I know my height is going to equal 15. My diameter is going to equal 16, which means that my radius is going to equal 8. And I can solve for my surface area, or my slant height, because my slant height squared is going to equal my height squared plus my radius squared. Slant height squared is going to equal 15 squared plus 8 squared, or my slant height is going to be 289. So I'm going to take the square root of 289. Now in this case, it works out perfectly as 17. And I have all the units that I need for my different formulas. My volume is just going to be pi r squared h. So my volume is going to be pi times 8 squared times 15. Or, in this case, my volume is going to be 1005 to 1 decimal place 0.3 centimeters cubed. My surface area is going to be 2 pi r squareds plus 2 pi r s. So this is going to give me, oh sorry, I'm thinking the wrong formula, plus just pi r s. So this is going to give me 2 times pi times 8 squared plus pi times 8 times 17. And I'm going to get a surface area in this case of 628.3 centimeters squared.